In this tutorial, I'm going to go over exam 4. But before I go over exam 4, I just wanted to give you some update. I just posted exam 4 to the Jupyter. Unfortunately, not everyone got 100. So I want to give you another chance on Friday, November 3rd. I will randomly choose 25 problem from 69 questions that I already posted to the Google Classroom. So on the weekend, especially tonight, tomorrow and Sunday, print it out, solve all the problem. If you cannot solve any problem, let me know on Monday. So let's go over exam number 4. Okay, so this problem, we have two cars. So let's draw it. We have two cars. Car number 1, we're going to call car A, and this is car B, right? And this is car A. Let's put car A and B at the same location. So you're going to call DA is equal to DB, right? It shows that the car A moves with 20 meter per second, 20 meter per second. And it shows that the car B moves with 15 meter per second, 15 meter per second. And it shows that the car A starts with, car B has some head start. So we're going to call it DI is equal to 200 meter. And DI for this one, we're going to call 0 meter. So from page number 6 of reference table, we know the equation dA is equal to DI plus VIT plus half AT squared. And for over here, we're going to use the same thing. We're going to write dB is equal to DI plus VIT plus half AT squared, right? So now we see that DI is 0 because dA is 0. Acceleration is 0 for both because the object moves with constant speed. So dA is equal to 20t. dB is equal to DI is 200 plus 15t. Okay, now over here the both cars meet, so that over there both cars meet. So we're going to write this equation is equal to, so let's bring it over here. This equation is equal to this equation, right? This equation. So what do you see? This equation equal to this equation. You see that 20 minus 15, which is 5t. 5t is equal to 200. So 5 is equal to 40. T is equal to 40. What does that mean? That means you're going to have to plug this over here. dA is equal to VI is how much? Well, we have the equation already. BI is 20 and this is 40. So dA is 800 meters. What does that mean? That means this car has to move 800 meters to catch this car, and this car would be moving over here 600 meters. Okay, 600 plus 200, 800, right? So this car moves 600 meters while this car moves 800 meters. So and at that location they're both going to be meet right here. So this was problem number 1. Let's go to problem number 2. Problem 2 is a roller coaster traveling with an initial speed of, so initial speed, always put the variable next to the quantity per second. Deaccelerates uniformly. Okay, so this is your acceleration. Full stop means, of course, VF. All right. How far does, so that means you have to find the D. So you have VI, you have VF, you have acceleration, you're going to find D. So this simply VF squared is equal to VI squared plus 2AD problem. So this is 0 is equal to VI is 15 squared, 225 plus 2 times negative 7D. So D is equal to 225 divided by 14. and 225 divided by 14 is probably 16. So 225 divided by 14 is 16. So 16 is the answer. Okay, we're gonna move to problem number 3. We're gonna move to problem number 3. Okay, so problem 3, a car moves west, this time west. Remember, west means negative. In a straight line on a highway, decreases speed from 30. So this is V initial. This must be negative because west. 2, this is V final, right? Meter per second in 2 seconds, right? The car average acceleration. So remember, the car is moving to the west. So let's see. The car is moving to the west. This is west. So this is the car, right? The car moving 30 meter per second and then moving 23 meter per second, moving 23 meter per second, right? So velocity vector is bigger, velocity vector is smaller, right? Why? Because acceleration must be to the east. If acceleration is opposite to the velocity, then the velocity decreases, the car slow down. All right, so our acceleration must be east or positive. Okay, so let's find out whether that's the case. A is equal to Vf minus Bi over Tf minus Ti. So Vf is obviously 23, negative, don't forget, because west, minus Bi is 30, Tf is 2 minus 0, so you have 7 over 2, which is 3.5. 3.5 meter per second squared, and this is positive, so is to the east. Okay, and now we're going to go to problem number 4. So let's go to problem number 4. The speed of a car increases from 2.5 meter per second to 9 meter per second, right? In 3 seconds, right? Read the question carefully. As it accelerates uniformly downhill, right? Okay. What is the magnitude of the acceleration? Okay. So again, this time you have acceleration is Vf minus Vi Tf minus Ti. You're just going to use the formula. Vf is 9, Vi is 2.5, Tf is 3 minus 0. So you have 6.5 over 3. So you have 6.5 divided by 3, and that would be 2.2. Acceleration is 2.2 meter per second squared, and that would be B. That takes us problem number 5. So let's go to problem 5. So problem 5, 2 stones. So this again Galileo's problem. You have a stone. Let's draw the stone. You have a clip, and stone A is sitting over here at the edge of the clip, right? And you have another clip, right? So they are at the same height, right? They are at the same height, and they are. Another cliff is this cliff. Initial speed of this one is 15 meters per second. Another one, let's say, is the same size. So same size. This is B, right? This is B. So this one speed is 15 meters per second. 15 meters per second. And this one speed is double, 30 meters per second, right? 30 meters per second. This is Vx. This is Vx, right? Okay, now how long, what time? It's going to take some time to land on the ground, right? Time to land on the ground. It says that horizontal means Horizontal means Vx. Please understand that, right? So only one contribute to one type of velocity contribute to time it takes to land the ground, and that is the vertical component of the velocity. So velocity has two components, Vx and Vy. Vx is responsible to increase the range, and Vy is responsible to for the time. Big Vx is big range. Big T is big Vy. Big Vy is takes big Vy takes a small time, right? If you have a big Vy, that takes time, a small time, right? And a small Vy, small Vy takes big time for the object to land. Okay. All right. So good. If that is the case, then Vy for this one is 0 and Vy for this one is 0. Since Vy is only responsible for the time it takes to the land, both objects will touch the ground at the same time. Okay, if this takes 2 seconds, this will take 2 seconds. Okay, and that's going to take us next problem number 6, problem 6, problem 5, and there is no 6, problem 5 is problem 6. Oh, okay. Problem 6, let's go to problem 6. So this is the problem 6. Okay, so let's go over problem 6. Now 2 seconds, right? If you drop after 2 seconds, so you're going to verify that object A and B are dropped, right? Object A has mass m, so object A has mass m, and object B has mass 2m, right? So this one is bigger object, right? Okay, and they are dropped from same height, right? They are dropped from same height, right? So we are trying to find 1 second later and 2 seconds later. Okay, 1 second later, what is the distance this one gonna fall? This one gonna fall at the 1 second later. This one gonna fall 5 meter, and this one also gonna fall 5 meter. Okay, at the 2 seconds later, if we use negative 10, if you use 10 meter per second square as acceleration due to gravity, if you use negative 10, then negative 5 meter, negative 5 meters. Okay, if you use negative 9.8, then it falls negative 4.9 meter and negative 4.9 meter. Okay, good. 2 seconds, how much does it fall? 19.6 meter, and this one 19.6 meter. Now we're going to write the velocity. At the end of 1 second, the velocity would be what? The velocity would be negative. At the end of 1 second, velocity would be negative 9.8 meter per second, negative 9.8 meter per second, right? And at the end of 2 seconds, velocity would be 19.6 meter per second, 19.6 meter per second, right? So as you see that the velocity at the end of 2 seconds would be the same, okay, for the small object and big object. If you double the mass, also it doesn't affect the distance it falls. It falls the same distance, okay, at the end of 2 seconds, and it also gains the same velocity at the end of 2 seconds. That takes us problem number 7. So problem 7, So problem 7, what are you going to do? We throw a ball up with an initial velocity 29.4 meter per second. What is the maximum height? So you throw a ball in the air with velocity 29.4 meter per second. We are trying to find right over here what is the maximum height. What do we know right here? We know that the velocity at max height is 0. We're going to use that fact to find the height. Okay, so we know that vf squared is vi squared plus 2ad. Good. So velocity is 0, right? Because right here velocity is 0, and right here we use this fact to find the, because max height, when you max height max is when the velocity is 0, right? That's where the max height is. So 29.4 square minus or plus 2 negative 10 d, we are using g is equal to negative 10, right? So you have d is equal to 29.4 square over 20, and that gives you 44.1. That takes us to the next problem. So problem number 8. Now you throw down the ball at 0.5 meter per second, right? This time, since you throw down, it's going to take less amount of time, right? Because it's not a free fall, but it's throwing down. So there is some initial velocity, so it's going to take less amount of time. Good. Second, for height of 4 meter, what is the speed of the ball? 0.7 second after. Okay, good. So you're throwing down a ball. So you are right here, right? You are right somewhere right over here, over there. So okay, you are right over there. Okay, so you're throwing down the ball. You're throwing down the ball. So this is a DT graph, right? You're throwing down the ball, and with how much? Initial velocity is negative 0.5 meter per second, right? Height of 4 meters. So this is the height of 4 meter. You throw it. So this is 4 meters. Okay, it doesn't really matter. At the end of 7 seconds. So at the end of 0.7 second, let's say this is end of 0.7 second. What would be the speed? We want to find the speed. So remember, vf is equal to vi plus at or gt. So vi is negative 0.5 minus 10, and t is 0.7, right? So you have vf is equal to negative 0.5 minus you have 7, right? So so you have 10 times 0.7, that is 7, 7 plus, so you have 7 plus 0.5, and that is 7.5, right? So this is the answer, because you try to take the speed. So if velocity is negative 7.5 meter per second, then absolute value of velocity is speed. Speed must be the positive 7.5 meter per second. Since we used negative 10, we got 7.5. If we did use negative 9.8, we would have gotten 7.4. Okay, so 7.5, 7.4, we use negative 10, that's why we got 7.4. If you did use negative 9.8, you will get 7.4. Okay, so that's take us to problem number 9. Okay, so what is the speed of 2.5 kilogram? Galileo told us that the heavy object and light object fall at the same rate, touching the ground at the same time if they drop from the same height. So we're going to totally ignore what you're dropping. It doesn't matter what you're dropping. Absolutely ignore that. If the object fall 12 meters, right? Okay, if the object fall 12 meters, what is the speed? What is the speed of after it has fallen? So Okay, so we're going to try to find the speed. Okay, to find the speed, first we have to find the time. So let's first find the time. Vf is equal to d is equal to half at square, right? Because you're dropping it. So 12 is equal to negative 12 is equal to negative 5t square, right? So negative negative cancel, t square is equal to 12 over 5. So t is equal to 12 divided by 5, and then is square root of 2.4, and that would be 1.55. Now Vf is equal to Vi plus At. Okay, so we're going to try to find the velocity of the object at the end of 12 meters. So this is 0, this is negative 10, and this is 1.55. So 1.55 times 9.8, and that is 15. So Vf is 15 meter per second, right? This is the answer. Okay, that takes us problem number 10. Okay, problem 10. A rock falls from the rest of high, some cliff. Okay, so let's draw the cliff. This is the cliff. Okay, and height is h, right? How far has the rock fallen when its speed is 39? Okay, so you have a rock, right? You have a rock, it does fall, so it is falling now, right? It is falling. Okay, right here the rock velocity is 39.2 meter per second, right? Physics allow you to empower you to solve all type of problem. You drop a rock, you try to find the distance of the rock when its velocity is 39.2 meter per second. So this seems to be very easy problem. So first you need to find the time. So let's first find the time. You have Vf is equal to Vi plus At, and then you want to find the distance, because this asks you to find how far has the rock fallen. So Vf is equal to Vi is of course 0 and negative 10. Well, velocity final is given. Velocity final is 39.2 is equal to 0. You have minus 10t, right? So velocity is, we're going to use negative because it's falling. So negative negative cancel. So you have t is equal to 3.92, right? Okay, now we're going to find the d. How can you find the d when you know the t? Right here, t is 3.92. So the d would be half At squared, right? So d is half, you have negative 10, and you have t is 3.92 squared. So 3.92 squared times 10 times 0.5, which gives you 76.8. So 76.8 is close to 78.3. If you did use 9.8, then you would get 78.3. Let's see how you're gonna get 78.3 if you use 9.8. This time I'm going to use 9.8. Okay, let's see what time. So Vf is equal to Vi plus At, right? Let's use 9.8. Vf is equal to 0, negative 9.8, and this is t, and this is 39.2, right? Negative. So 39.2 divided by 9.8, and that is 4. So t is equal to 4. So t is equal to 4. Excellent. Now d has to be what? D has to be half At squared. So d is half negative 9.8, and this is 16. So 16, 8. 8 times 9.8. So 8 times 9.8 is actually 78.4. 78.4. Okay, excellent. So we got 78.4. Now we're going to go over problem number 11. Okay, so in problem number 11, a student standing on the roof of 50-meter high building. So this building is 50-meter high, right? 50 meter, right? 50-meter tall building, and kicks a stone at horizontal speed. He kicks a stone like this with a horizontal velocity This is a stone, this is a stone. So he kicks his stone with horizontal velocity 4 meter per second. How much time is required? So Vy has to be 0, right? Horizontal velocity has no business whatsoever with the time it falls. Horizontal velocity has no business with the time it takes for an object, for the rock to fall. Only the vertical velocity. So dy is equal to VIYT plus half AYT squared. Now you know this is 0. The building is 50 meter tall, is equal to negative 5t squared, right? So you have negative negative cancel, you have 10t squared. Sorry, you have t squared is equal to 10 and t is equal to 3.19, right? So 3.19. That takes us problem number 12, right? Problem number 12. Okay. All right. So 5 kilogram object is just from rest, right? So rest means Vi is equal to 0, right? Falls freely 22 meters. So it falls 22 meters and it falls for 3 seconds, right? Near the planet Earth. Compared to the not near the planet Earth. No, it's falling somewhere else. Because the Earth 3 seconds it can fall 45 meters, right? 3 seconds on the here on Earth, 3 second object fall 45 meters. Here 3 seconds it falls only 22 meters, so it's not Earth, probably Moon, not sure. Compare not Moon, something else, not sure. Compared to the acceleration due to gravity near Earth's surface, the acceleration. Okay, let's find it out. So we know that Earth acceleration due to gravity here on Earth, we use G for Earth, negative 9.8 meter per second square, right? Now let's see, find this one. Let's see how this one, half at square, right? Half at square. Now d is negative 22 is equal to half, a is a, and t is of course 3 square, which is 9. So negative 22 is equal to 4.5 a, right? So a is equal to negative 22 divided by 4.5, 22 divided by 4.5, and that is 4.9, negative 4.9. And negative 4.9 is actually half of 9.8, so 1/2 as great. Rock falls from rest, VA is 0, a vertical distance of 0.72 meter, so rock is now here, and the distance from here to here is 0.72 meter, okay, to the surface of a planet in 0.6. So the time is 0.63 second, right? Okay, what do we want to find? Magnitude of the acceleration. We want to find the acceleration. We know that acceleration is constant, but we know how much, but we also can figure it out. If it was Earth, then it would have fallen much more than 0.72. So d is equal to half at squared, right? Now d is negative 0.72 is equal to half, a is 0.63 squared. So 0.63 squared times 0.5 is negative 0.72 is equal to 0.19845 a. So 0.72 divided by 0.19845, and that would be 3.6. So acceleration is negative 3.6 meter per second squared. So that is the absolute value of the acceleration of this planet we are talking about. Okay, so now next, problem number 14. Okay, so what is 14 talking about? An astronaut is standing on a platform of the moon, drops a hammer. All probably David Scott, 1972. He dropped hammer and feather, and they both touched the ground at the same time. That's really true. He did it in 1972. David Scott. Check it up. David Scott. 1972. Okay. So, okay, 6 meter vertically 2 point. Okay, so he dropped hammer this was done on the moon, so I actually know what is the answer, 1.6. But let's find out. D is equal to half at square, right? So the D is 6 meter, negative 6 meter, half a, and it falls 2.7 square. So 2.7 square, 2.7 square, right? Times zero point 0.5. So negative 6 is equal to 3.645 a. So 6 divided by 3.645, 6 divided by 3.645, and that is 1.6. So acceleration due to gravity on the moon is 1.6. All right, so we are talking about moon. Okay, we are talking about David Scott. We are talking about 1972. Okay, and that takes us to 15. Okay, again, astronaut drops a hammer from 2 meters above the ground surface of the moon. If the acceleration due to on the moon is 162 meter per second square, how long will it take for the hammer to fall the moon surface? Okay, so how long? Here we want to find the time. So D is equal to half at square, right? The D is 2 meter, negative 2 is equal to half negative 1.62, and then t square, right? So negative 2 is equal to 1.62 times zero point 0.5, and that is negative 0.81 at t square. Negative negative cancel. 2 divided by 0.81, and that is t square is equal to 2.469. So t must be 1.5 or 1.6. So t is 1.6 second, right? Okay, and that takes us problem number 16. Right now, that takes us to problem number 16. Okay, so problem 16, a ball, you throw a ball, right, horizontally. Horizontally means Vx is 24 meter per second. That's what horizontally means, per second, from the top of a cliff, right? If the ball hits the ground 4 seconds later, approximately. So if you throw a ball with Vx from the cliff, top of a cliff, which is h meter long, with 24 meter per second, that 24 has no business with the time it takes for the object to fall. Only Vy has something to do with the time it takes. That's why when Vy is more than 0, then or less than 0, it takes less time. Okay, so what does that mean? We want to find if the ball hit the ground, approximately how high the cliff. So we want to find the cliff, how high the cliff. Okay, so it falls how long per second at the top of the cliff if the hits the ground 4 seconds later. So we kind of know it, but d is equal to half at square, or d is equal to vat, d is equal to vat plus half at square, right, at the y direction, at the y direction. So how high in the cliff is this? Is 0, so this is half, this is negative 9.8, and this is 4 times 4 is 16. So dy is this is 4.9. All right, 4.9, which is 5 times 16, which is 80. So it is almost 80 meter high, or you can say 78, because 4.9 times 16 is 78. That takes us problem number 17. All right, so problem number 17, I ask you to find the acceleration from 6 to 8. What is the acceleration here? So I'm gonna ask you to draw this graph. So let's draw this graph, exactly this graph. Okay. Okay, so I'm gonna move this graph over here. So this is 4, and this is 8, and this is whatever it is, and this is whatever it is. Okay, so I'm gonna move this over here, 8, right? Okay, 8. Okay, Good. This is 8 and this is 16, right? Okay. So the displacement for this one has to be what? 8. Displacement is 8. 16 minus 8 is 8. Okay, good. Now, this is dt graph, right? This is dt graph. So I want to convert it to vt graph. If I do want to convert it to vt graph, how am I going to do that? I want to do it here. Convert it to vt graph. Okay, so I see that the velocity over here is maximum, velocity over here is maximum, whatever it is, velocity is max, and velocity is 0. That means the velocity is velocity and acceleration is opposite direction. That means velocity is positive, acceleration is negative, right? All the time, all the time. Whatever acceleration it is, acceleration is negative. That's why object is slow down from maximum to 0. Good. So then my maximum velocity, whatever it is, this is vt graph, my maximum velocity, my velocity is 0, my velocity is 0. This is velocity versus time. Good. Now I know I have area under the graph, area under the vt graph, area under the vt graph I also happen to know, and that is 8, right? Area under the vt graph is 8. So I'm going to write the equation. Area is equal to half bh. Area has a name, b has a name, and h has a name, right? Okay. So the displacement I already know, 8. Half. Time I know. The time from 8, between 8 to 6 is 2. And then velocity, 2 cancel. So velocity is 8. I know that velocity is 8. And I know that the time is, velocity is 8. And I know the time is 2. Okay, so once I have the velocity versus time graph, I can convert it to acceleration versus time graph. So acceleration versus time graph. Now, the slope of velocity versus time graph is acceleration versus time. But I don't need to know that. I know 2 points, right? I know 0, 8, okay? And I know 2, 0, right? So I have x1, y1, x2, y2. So slope is y2 minus y1, x2 minus x1, right? y2 is 0, minus y1 is 8, x2 is 2, minus x1 is 0, right? Okay, so minus 8 over 2. So m is negative 4. Now, when you have slope of delta v over delta t, there is a name of the slope, acceleration. Okay, because this is actually delta v, this is actually delta t. All right. Okay, so negative 4. So negative 4 is the acceleration. So the answer to the the problem number 17 is negative 4. Okay, that takes us to problem 18. Problem 18 is displacement versus time graph. They ask us to find the average speed. Average speed has a formula. Speed is distance versus distance over time. All right, do not confuse with this one. V is equal to Vi plus Vf over 2. This is you're going to use only when you have velocity versus time and there is a graph, let's say this graph. So you can find the average velocity by this equation here. Average velocity between these two, let's say this two, average velocity if I have 8, so average velocity you can use this formula, okay? But you cannot use this formula for dt graph. This is displacement versus time graph. This is the only equation to use. So the distance, they ask us to find it during fast 4 seconds. So this must be 4. And during fast 4 seconds, it moves how long? It moves 8 meters, right? Okay. Fast 4 seconds, it moves 8 meters. So 8 divided by 4, which is 2 meters per second. That takes us to 19. Okay, 19. What are we going to do? What are we doing? 19. We are trying to find what is the total distance traveled by the car during 6 seconds, right? 6 seconds. So I have half bh, and I have bh, and I have bh, right? I have bh. Okay, let's first do half bh. Okay, so area is equal to, so I'm going to do half bh plus bh. So let's do half bh. Half b is 4, h is 10, plus b is 6 minus 4, 2, h is 10. Okay, so let's calculate it. 20 plus 20 plus 20, 40. Okay, that takes us to 20. Problem number 20. Problem number 20, I ask you, if you throw if something moves, I ask you at 8.5 seconds, how much does it move? What would be not how much does it move? At 0.5 seconds, what would be the object displacement? This is 8.5. What would be the object displacement? Okay, so this is divide and conquer. What does that mean? Please pay attention. This is going to be in the test on Friday, November 3. So this is green. Okay, I'm going to make it bigger. So this is green. Okay, and this is a triangle, a green triangle, if you want to call it. Okay, so I'm going to say green. And this is red, and this is red triangle. Okay, this is red. Okay, and I'm going to call it a red triangle. Red plus red is equal to, this is green, I'm going to call it green. So this is green. All right, this is green. I'm not going to cover up those numbers because I need them to calculate it. So I'm not going to cover up those numbers. Not covering up the number. Okay, and I have, this is green and this is red. Okay, so this is red. I'm not going to covering up the 8.5 thing. Okay, all right, so this is red. So okay, green plus red is equal to green plus red. If this one is 50, this one has to be negative 50. Okay, and if you add them together, they have to be 0. Let's see. So this one is half bh, and this one is half bh, equal to, this one is half bh, and this one is bh. Okay. Okay, so half bh, so half, so this is half, b is 3, h is 20, plus half, b is 5 minus 3 is 2, h is 20, equal to half, b is 7 minus 5, 2, h is, be careful, h is negative 20, plus b is 8.5 minus 7, 1.5, h is negative 20. Okay, so now we can cancel. 2 goes to 20, 10, so 30 plus 20 is equal to negative 20, negative 30. So 50 is equal to negative 50. So total displacement is 0. So total displacement of this thing is 0. What does that mean? That means at 8.5 seconds, object total displacement would be 0. And that is what you needed to do. And what is the object total displacement at the end of 8.5 seconds? And that is 0. So that takes us to problem number 21, right? 21, Again, David Scott, that's what David Scott did on the moon in 1972 to Galileo's hypothesis that heavy object and light object fall at the same time. So you have the balloon, which is very light, and you have a tennis ball, which is a little heavier than balloon. However, both has to touch the ground at the same time because they fall from the same height. Okay, all right, so that's what it is. So the baseball and balloon fall at the same rate and touching the ground at the same time. Okay, next. There are three problems over there. These are conceptual, so I'm not going to do any math. And of course, as you can imagine, I'm a little bit tired. So I'm just going to do it here. Who is constant? So who is constant for freely falling object? The acceleration is constant. Okay, when object fall freely, acceleration is constant because distance versus time, which is quadratic. Speed versus time, which is linear. Acceleration versus time, which is of course constant. Okay, for free falling body. As an object falls freely near surface of the earth, its velocity increases. As you see, velocity starts from 0. At the end of 1 second, velocity is 10. At the end of 2 second, velocity is 20. So velocity increases linearly. If the mass of an object were double, the acceleration due to gravity is same, is because the mass has no effect on acceleration due to gravity. And when you look at the equation, there is no mass. This is distance, this is gravity, acceleration, and this is time. There is no mass to the equation. So mass really play no business in terms of how long it does take for an object to fall, because there is no mass in the equation. Also intuitively you understand, and we did that experiment in the classroom. We put things like this on top of each other, and this can create vacuum for this one, so it falls at the same time, because if you ignore the air resistance. In this case, you don't have to, because the clipboard creates vacuum for the paper. 4 seconds, how much? So you know that this is a VT graph or ST graph. So area under the graph, there is a name, which is distance, which is half BH. So half B is 4 and H is 2, right? 2 to cancel, so it's just 4 meters.